a number of guests duly introduced by fellows beg leave to attend your meeting. Is it your wish that I welcome them in your name? Can I particularly welcome Dr. Daniel Attard, Deputy High Commissioner and Chargé d'Affaires of Malta, to our meeting this evening. Very warm welcome to you. Minutes.
Society of Antiquaries of London, ordinary meeting Thursday. Who was that?
Got the recording.
I will start again. Society of Antiquaries of London, ordinary meeting Thursday, 7th of October 2021, Burlington House and online. Professor Martin Millett, President, in the chair. The minutes of the previous ordinary meeting of Thursday, 8th of April 2021 and the anniversary meeting of 24th of June 2021 were read and signed. The certificates of candidates for election were laid before the Society and ordered to be suspended in the usual manner. The following, being in attendance and having signed the obligation required by the statute, were duly admitted fellows: Andrew Rudd and Alexandra Guider. The President announced that Mr. John Lewis, FSA, General Secretary, will be retiring in April 2022, and that the search for his replacement has started. The Honorary Secretary reported back from the Library and Collections Committee, which met earlier that day. The President then presented the Society's Gold Medal to Colin Lord Renfrew, MA, PhD, FBA, FSA, and the Honorary Vice President of Society of Antiquaries London, Mr. Paul Drury, presented the Society's medal to Dr. Stephen Johnson, DPhil, FSA. The following communication was then laid before the Society: recent fieldwork on hill forts and other earthworks in Wales by Paul Belford, FSA. Thanks were returned for this communication. The President announced that the next meeting will be on Thursday, 14th of October. After announcing a wine reception to follow, the President closed the meeting.
Is it your pleasure that I sign these minutes as a true and complete record? Thank you. Remembered my pen today. Certificates.
Thank you. Anna Forrest, BAMA, a senior public-facing curator at the National Trust who has specialised in furthering the understanding of some of the Trust's lesser-known vernacular sites. Krista Gardner von Teufel, PhD, a scholar in Italian Renaissance art, who has been visiting professor at Harvard University and a senior visiting fellow at Villa Itati. Alexander Gerds, BAMA, PhD, Associate Professor, School of Archaeology at Oxford, who has researched the Mixteca Alta, Mexico, Honduras, Colombia, Panama, the Lesser Antilles, Peru, Chile, the US, and Europe. Helen Gitos, BA, MST, DPhil, Associate Professor in the Early Medieval History of the British Isles at Balliol College, Oxford, currently working on English as the forgotten language of the pre-Reformation Church. Linda Grant, BA, MA, PhD, an early modernist working on book history, discourses of love and the erotic, pornography, and the Renaissance body. Charlotte Hedenstierna Jonsson, BA, MSc, PhD, senior researcher in the Department of Archaeology and Ancient History at Uppsala University, who is a specialist in the Viking Age. Norman Jones, MA, PhD, Emeritus Professor of History, specializing in the Tudor period, especially politics and religion. Robert Kinsey, MA, PhD, development editor at an academic publisher with research interests in medieval English gentry and nobility, funerary monuments, and heraldry.
Is it your pleasure that these certificates be suspended in the usual manner? Admissions.
Following being in attendance and having signed the obligation required by the statutes, desire to be admitted fellows. Rowan McLaughlin, Kelsey Wilson Lee. Rowan McLaughlin.
Rowan McLaughlin, under the authority and the name of SocAntiquaries.
Kelsey Wilson Lee.
Kelsey Wilson Lee, under the authority and the name of SocAntiquaries. We now come to the main business of today's meeting, which is to hear a paper from two of our fellows, Caroline Malone and Rowan McLaughlin, just admitted. Caroline has a long and distinguished history of research, did her PhD at Cambridge with the British School at Rome, supervised by Colin Renfrew. She's subsequently worked in a whole variety of institutions, from the Alexander Keeler Museum, Avebury, beginning of her career, through lectureship at Bristol, posts in Cambridge, British Museum, now professor at Queen's University, Belfast. Rowan McLaughlin is a graduate of Queen's Belfast with a PhD research on human teeth. He's held a variety of postdoctoral positions, including on the project we're hearing this evening, and is currently a postdoc on an ERC-funded project in Deuce at the British Museum. The lecture this evening is revisiting the origins of prehistoric Malta, temples, landscape change, the work of the ERC Fragsus Project 2013 to 2018. Beg your pardon. Welcome. Thank you.
Ladies and gentlemen, President, thank you very much indeed for this invitation to talk about the Fragsus Project. We want to start this lecture by thanking the Society for enabling us to speak about the recent work undertaken on the Maltese Islands funded by the European Research Council project. We are speaking on behalf of a very large team of colleagues in Britain, Ireland, Malta, Australia, Canada, Italy, and Greece. As this slide shows alone, we are working also with many institutions, and over 70 individuals contributed to the work we're going to talk about. And we're grateful to everyone involved. We last reported on our work in Malta and Gozo in 1996, when the Society kindly permitted us to hold a lecture relating to the exhibition on Maltese prehistoric art that celebrated the opening of the Malta High Commission at Malta House, which is just up the road in Piccadilly. We also want to acknowledge how important the Society of Antiquaries has been over the many years in supporting our work, which was in the form of annual fieldwork grants. And frankly, without those, we wouldn't be here today to hear the new work that we've been able to do. Now let me turn to Malta and Gozo to remind you of this quite small and remote and arid set of islands set in the middle of the Mediterranean. In many ways, they mirror the islands of Orkney in their richness of Neolithic antiquities. And they have an extraordinary density of supremely important monuments. Between them, Gozo and Malta extend to barely 316 square kilometers, and they are today relatively treeless islands with thin, dry soils, aggressive levels of erosion, and threatened by rapid, intensive urban development. As these images on the screen show, almost 1/3 of their land surface today is developed with buildings, and even the airport runway dominates the central zone of Malta. These are very small islands, and in prehistory, they offered settlers comparatively little space, limited seasonal water supplies, and almost no natural resources other than soil and sun, limestone, and harbors. Located over 80 kilometers from Sicily, the islands are also some of the most remote from the mainland coasts of the Mediterranean. So the question arises, when and why were the islands first occupied and settled? And what was that settlement? And how was it sustained? And how was it viable? The most characteristic aspect of the Neolithic settlement of Malta are the unique megalithic buildings called temples. These occur in clusters of buildings, and perhaps over 30 so are recorded. The shape of the temples can be defined as cloverleaf lobed rooms that open from central corridors, entered by distinctive portals that cut through high megalithic enclosing walls. Some early structures had just 2 or 3 oval rooms, while others evolved into complex multi-roomed structures such as Tarshin and Hajareen. Invariably, these complexes opened onto large arenas or forecourts, sometimes marked by artificially leveled terraces, and often seeming to align on particular directions and viewpoints. Indeed, Menidra, on the right-hand bottom part of the diagram of plans there, aligns on the summer solstice, for example, and clearly there is a massive symbolic significance in every element of the buildings and their context. But this is not the moment to debate this. We must explain how the temple background influenced our project and the goals of Fragsus. In 2013, when we started, it represented a full century since Zamit and Ashby were at work on the very sites we intended to revisit, and almost 2 centuries since the work first began at Gigantea, and indeed over 50 years since the important site of Scorba, which I shall say more about, made its impact and which was published by the Society. This long period has seen archaeological science evolve enormously, but the very data we are looking at has now begun to diminish irreparably in the ever-eroding environment of Malta. How indeed could suitable environmental data be retrieved when the very soil that contained it has all but washed away? The full title of this project, Fragility and Sustainability in Restricted Island Environments, Adaptation, Culture Change, and Traps in Prehistory, was given the name Fragsus, as one can see, because it's a simple way of putting together an acronym. But we have 5 important questions to pose here. Because since 2007, when I first went to Queen's Belfast and talked with my colleague Chris Hunt, we began to talk endlessly about why the temples were there, how they were sustained, why they ended. And eventually we came up with these 5 questions. What was the impact of human settlement on prehistoric Malta? A very simple question. How did a very small island community in prehistoric times manage to sustain dense, complex life for what apparently was several thousand years of unbroken occupation? What sort of agriculture was used and what did people eat? We hardly knew anything about this. And so too was the size and nature of the early Maltese population. We'd excavated, as I will come to say in a moment, a large population in one site. So we wanted to know far more about it. And we also wanted to know why it came to an end. And the question is, was there social or economic or environmental failure at the end of the temple culture? And as you can see from this diagram, we wanted to bring together an interdisciplinary, multidisciplinary approach to tackle this question about looking at the prehistoric community itself. I'm showing the same slide again, but just with all the names of the very many people, over 30 specialists, and senior colleagues came to work on the project, about 10 postdoctoral assistants, at least 6 PhDs. It's been a tremendous invigoration, if you like, for questions about Maltese prehistory. And our target activities, as you can see on the left of this slide, to look at settlement, something that was hardly known about because the temples did not really represent settlement. The economy that underpinned that settlement, and the population history of the people, the dietary studies and DNA and things like that, which we are now able to approach. And to attack the problem of the environment, we wanted to look at cause to understand the vegetational history of the Maltese islands and enable an environmental reconstruction of this past set against, hopefully, a very strong chronological control of AMS and OSL dates that would link the whole thing together. Well, we need to go back to the early past of Malta to see that archaeology has been taking place for over 200 years on these islands. People who were recording the megalithic monuments from the 1600s onwards, when the Knights of St. John were beginning to identify these monuments. But it was only during the Grand Tour years from the 1780s onwards, when we had John O'Ell, the illustrator of Louis XVI, recording some of the sites on Malta and Gozo. And these were then followed up with rather drastic and dramatic excavations by the governor of Gozo, Otto Bayer, recorded by Charles de Brockdorff. A little bit later, we had Vance and the Royal Corps of Engineers devastating 2 of the major temples at Amnidra and Hajarim in the 1839-40 period, basically clearing the temples out and not really leaving very much behind them. Over the years, people began to think that these monuments predated the Romans and must be Phoenician. But that was probably wrong. And it was only in the 20th century, when at the turn of the century, the major developments on the islands began to lead to proper excavations at last. And initially, this was at Hull Saflieni, the great hypogeum, shown on the screen there, this wonderful underground rock-cut monument. And then very soon afterwards, Zamit, who had become not only rector of the university, but the director of the museum and a major scientist in his own right, began to run excavations at Tarshin from 1915 or thereabouts. And here are some of the photographs of his work. And indeed, he, standing by some of his inscribed rocks and the great bowl that he reconstructed, he set in train a whole series of questions about the origins of Malta. And realizing the task was going to be far too much for him, he invited colleagues such as Thomas Ashby and Eric Peat, Margaret Murray, Dorothy Garrod, Robert Bradley, and many others to assist him in his work. And it was Thomas Ashby of the British School at Rome with his young colleagues, Bradley, who was a civil servant, and Eric Peat, who was barely a student, I think, at that time, started work on a program of looking at some of the smaller and lesser temples, Cordine, the 3 Cordine sites, and I show you some of the plans here on the left, and their excavations around 1908, 1909, and then followed up at Santa Verna on Gozo, the pictures on the right there. Robert Bradley's standing there in his spats in that middle picture, looking very pleased as the local workmen clear the site. And when we found it, it was pretty well in the same condition. But they did excavations which were recording stratigraphy for the first time. They recorded the depth and the nature of the composition of the soils they went through, and they kept all the finds for the very first time. So this was a revolution that was relatively short-lived, unfortunately. But before I go on any further, I want to acknowledge that the Antiquaries, Society of Antiquaries, has had a long association with Maltese prehistoric work. And Pete and Ashby and Zamit and others were all members, of course, but they also published. And even from the 1820s, we've got reports in Archaeologia and in the Antiquaries Journal that recorded some of these excavations that I show there, culminating in the really important work at Scorba, the Temple of Scorba, that David Trump at Cambridge University managed to put together in 1966 and was published by the Society. Now, this was a really transformative excavation because it provided the very first radiocarbon dates for the Central Mediterranean ever. It also provided dates for the Maltese sequence, which for the first time was put into a chronological context. And it changed the theories about Mycenae and Stonehenge and all those old ideas that used to flourish until about 1960. It was absolutely pivotal in changing ideas. And indeed, Colin Renfrew then took this up with a vengeance in his work in the 1970s, redating Stonehenge and all sorts of things. But we have to thank the two colleagues, John Evans and David Trump, for their amazing work on Malta that set up the questions about sequence and colonization and the nature of the temple culture itself. And John Evans produced this fantastic book, Prehistoric Antiquities of the Maltese Islands, which he basically put together during the mid-1950s when he was a fellow on the islands of Malta, really looking at all the work, the post-war damage in the museum. And it was published in 1973, a little bit after Scorba. The Scorba work, of course, was David Trump, but he did a great deal to popularize the Maltese temple culture. He wrote guidebooks, he worked with the museum, and for 5 years, he was the curator of the museum. Both of them made extremely important observations and raised all the questions that we wanted to address in this project. Scorba, I can put here just in context, you can see the plan there with its various phases of occupation from Ardalam and Scorba to Zebuj and Mjan and Gigantea. And these are all the pottery phases or occupation phases of the early Maltese island Neolithic period, culminating in one place with the temples above much earlier Neolithic settlement. Well, we were intrigued by these questions, and when the opportunity came in 1987 to start a new project in Malta, one of our first tasks was to go with David Trump, and you can see David Trump in that middle picture there with Joe Attard, with a discovery of a small section along the main road at Ein Silem in Gozo, which was basically the floors of a prehistoric house, which we then excavated over a 2-week period. And you can see on the left and the right of this picture, the structure of half a house, 2 little rooms, or 1 little room and a big room, and mostly made of mud brick and possibly timber structures as well. And this was one of the first of the real houses of prehistoric Malta. It added very significantly to the Gigantea period. But it was only the start of also the Gozo project, which from 1987 to 1994 excavated the Shara Circle on Gozo. And as the picture on the cover of Mortuary Customs on the right of the picture shows, this was recorded in about 1820 as a major excavation that was never, of course, written up. And the whole thing had been covered over and forgotten. And we were able to go back to excavate this site over this 8-9 year period. And it was the second major burial site of the Maltese island, a cave hypogeum, very like Hal Saflieni. And it dated indeed from about the Zebuj period, about 3,900 BC, to about 2,500 BC. And it produced about 220,000 body parts. Recently, we've counted those body parts, and there's over 11,000 teeth. So that gives you a bare sort of number of about 1,000 people, probably. Importantly, it had radiocarbon dates in context with the artifacts that were related to it, and a survey and an excavation that enabled us to start again thinking about the scientific questions that we needed to pose on this project. Well, a survey also accompanied the Gozo project, and here's a plan done by Sarah Boyle, who did a PhD on the subject, and put all the data together, showing the changing, pulsing movement of settlement around the Gozo landscape. Different areas were occupied at different times, different aspects and soils, but the proximity to water and soils is always important. And so too with the later temple sites of Gigantea, Sant'Ivana, and the Brockdorf Circle itself in the use of the landscape. Now, we were able to revisit this survey, in particular in about 2014 as part of our initial work, because the toilet block at the Gigantea temple, the larger red square on that photograph, the aerial photograph, was demolished. And when it was demolished, it exposed a prehistoric land surface beneath with megaliths erupting. The toilet block had been put in about 1959 or so, without much care and attention to what was underneath. And this opportunity, this vision of prehistoric land surfaces below, was an opportunity for environmental sampling and excavation, which I will talk about in a bit more detail. But going back after our Gozo project, which finished in 1994, 1995, and took about 15 years to write up. There were a lot of bones. Meanwhile, my colleague Chris Hunt started work on the pollens of Malta. And here is his pollen diagram, which with his PhD student, Frank Carroll, brought together during the early 2000s. And what it dramatically demonstrated, this was a core from Marsa, which is the racecourse area just south of Valletta in Malta. What it showed absolutely was between the earliest Neolithic and the Temple period, the most dramatic removal of trees in the landscape. And so we can project that the landscape changed from a gently wooded Mediterranean world of reasonably good soil and humidity to one which was absolutely stripped of its vegetation. And of course, it must have been the humans that did that, people who arrived and changed that landscape. So this was really the trigger for our Fragsus project, where our goals were to get chronology, to get human remains studied properly, to find economic data from new temple sites, settlement sites, and whatever, to examine the landscape and the vegetation and reconstruct it, to understand the farming practices and the sustainability of these tiny islands, and the changing soil structures that supported that agriculture too. And with it, a pottery sequence, a cultural sequence that could be tied in accurately to a radiocarbon dating sequence. And it came to the long question I've been pondering all my career, is why did the temple culture come to an end? It lasted 12 to 1500 years without a break. One of the longest lived early civilizations anywhere in the Mediterranean. You know, more than a millennium without a break. What brought it to a close? Was it the environment? Was it the people themselves? Was it the climate? Was it the food? What was it? So the starting point was to take cores from that landscape. And here are my colleagues coring away, the state taking samples from the soil cores. Basically, you drill into the soil, down, 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 as far as you can get. And we required GPS and radar and all sorts of things to try and find the deepest points of soil in the marine valleys around the islands. And we also looked at the old buried stratigraphies under the floors of temples, as we can see on the bottom right of the picture there, where we have sealed floors and black humic soil underlying the temples themselves, a hint of a world that has long since disappeared from Malta. Well, these are the coring sites, and as you can see, they're all on the coastal valleys coming down to the sea in Malta, where we've got possibilities of deep stratified remains, where hopefully there were going to be stratified soils intact and sufficiently undisturbed to provide a sequence. And so these are the cores, and you can see them lined up in the great drain pipe tubes, which are then shipped back to Belfast and studied in Malta, kept in the fridge for many years. They're still there if anyone wants them, and ready for sampling. So it was jolly hard work, but this was the starting point. Another starting point was excavation, and we excavated 6 new sites in Malta, and a great privilege it was indeed. And we thank the authorities, the superintendents of cultural heritage and Heritage Malta, for enabling this, because to get your hands on a temple is pretty hard in Malta. There aren't that many around, and they are highly protected World Heritage sites, so we're extremely grateful. So we concentrated on sites in the center of Gozo, temples at Scorba, Cordine, Gigantia, and Santa Verna, and a settlement at Tachaula, which you can see on the right of the picture here, and also in Nufara, which I'll talk about briefly, which is a Bronze Age site, to just give us some variable data. Well, Tachaula had been discovered in the 1960s when development was taking place, and it's now surrounded by houses, but it was preserved. The Ministry for Gozo protected it. And as you can see, we've got some Neolithic walls, we've got floors, we've got primary land surfaces, we've got plenty of pottery, and probably timber structures associated with a modest stone set of buildings, probably 3 or 4 houses at least, and probably a whole landscape was once there. At Santa Verna, we took on the temple that Ashby had looked at in 1911, and this is what we found on the left of the picture, a site almost identical to the one he left. But we were able to take away the backfill, go down through various deposits back to the original plaster floors, which you can see there in the middle of the picture, and the top right picture, and find the excavations done by Ashby, his trench at the top there, and David Trump's trench in about 1960, which also went to test that stratigraphy. Importantly, we looked in the landscape around it and found traces of the earliest settlement in the Maltese Islands, Ardalam. And you can see some of this impressed pottery here, which dates from at least 5,300 BC, probably 5,500 BC in part. So this was a very important temple site, enabling us to get a full sequence of prehistory. We then moved to Scorba, really to look at the Scorba sequence David had published and dated in the 1960s. And we wanted to just redate those sequences with AMS dating and OSL dating for optical stimulated luminescence. And there you can see on the left of the picture, the very small trench that happened to just go over 2 or 3 very significant walls, which are part of the earliest part of the Scorba site, going back to the Ardalam phase as well. At Gigantia, we were able to do geophysics and examine the WC block area. And on the bottom of the right, bottom left, you can see the 2 pictures showing the temple in the background and this small excavation that was very revealing indeed and produced probably some of the entranceway that had originally been in front of the temple coming up over the terrace there. Caudine on the mainland Malta is a little known temple. It was once part of a whole sequence and complex of monuments on the south side of the Grand Harbour. The others have completely disappeared under the factories and buildings, but Caudine was judiciously walled in about 1930 and has been protected as a result. And there is the original plan. And you can see on that plan the trenches that we were enabled to put in on the peripheral parts of the site with the University of Malta. And there's our excavations underway, revealing some of the stratigraphy around these early structures. Because Caudine was a very early temple, but one that had never been properly dated. It had been looked at by Ashby and others, by Evans in 1953, by Evans and Trump in 1961, but no radiocarbon dates. So we were very lucky to be able to examine it and get a fantastic sequence of pottery and dates. And then we finally looked at the Bronze Age, and the Bronze Age was just something we wanted to check because no temples were really in use in the Bronze Age, but a different regime altogether, a much drier, poorer landscape of fortified sites on promontories and hilltops and silos, which we used to store grain. So we excavated 2 silos, one of which was completely intact in Nufara. And we were able to do digital scanning and photogrammetric imaging and all sorts of things that really bring to life some of these very ruined structures. And this, as Rowan will say, was a very different environment indeed by the time we get to the Bronze Age. And just before I hand over to Rowan, who's going to talk about the science, here are some of the activities that this project went through, because being a big interdisciplinary project, you need to bring people together. And here's one of our team meetings. And I just point out the late David Trump, one of the last meetings he went to. He was absolutely delighted to be part of the discussions that were ongoing of a new look at Malta and a way of looking at it that he had been only dreaming of, I think. But we looked at pottery, we drew material, we sieved, we stored, we dated, all sorts of things went on archaeologically as well. And I shall now pass to Rowan.
Well, good evening. So armed with all these data, which as you can see from Caroline as mentioned, we had thousands of soil samples, we had tens of thousands of sherds of pottery. At these sites that we've excavated, and a bonanza of scientific paleo-environmental data that we had to make sense of. So it was my task, along with my colleagues who are active researchers in the project, to try to achieve answers to the questions that had been posed. And this evening, I'm going to recapitulate the exact questions from the original ERC grant proposal and provide some answers. Which hopefully are congruent with those of my colleagues. Some of my answers will be quite terse because it's very difficult to synthesize a large project like this into a short presentation, particularly actually is because we're still very close to that phase of very intensive work. A lot still remains to be digested. So what was the impact of human settlement in Malta? And how rapid was the progress of deforestation, erosion, and degradation? Well, to answer this, we turn to the landscape, the paleo-environmental coring, and we look at the deposits that have been unearthed in this process. And you can see over on the right-hand side of the slide, one of our sediment cores, which at the bottom is dark and rich, and it progresses through a brownish color of typical Mediterranean soil. And then over the course of the Neolithic and the Temple period, that brown color turns to gray and eventually ashen black and then pale gray. And then as we get into the modern era, at the top left of that sequence, it takes on the beautiful golden color of the Maltese landscape. But this is a sequence of gradual aridification and a reduction in organic material. And that is very significant because soil is one of the things that enabled prehistoric life in Malta. And it is one of the things that really binds together our synthesis of how we understand that prehistoric society worked. Molluscan remains as well as pollen from these cores enabled us to pinpoint a moment in time at around 6000 BC when humans first arrived. And after that, there's significant other indicators of erosion and anthropogenic impact on a very large scale, indicating that when agriculture first arrived at about 6000 BC, which is slightly earlier than the actual archaeological evidence that we have, it was a very rapid transformation of the entire landscape. So when did technical mechanisms to manage the environment develop? This is a very interesting question because agriculture in these kinds of semi-arid Mediterranean landscapes would be impossible today without irrigation and terracing. So were they doing this in prehistory? Well, to investigate this, we looked at, did a modeling exercise to look at the soil erosion, so the plastic properties of the sediments on the island surface today, and what would be necessary to keep these sediments from literally washing into the sea, be it differences in vegetation cover, terracing, and other management strategies, such as growing crops together, growing beans amongst the wheat, for example, to try to make the soil more adhesive to the surface. And well, we discovered during this modeling exercise that you really need to combine various, not a single strategy on its own wouldn't be effective. So the prehistoric occupants of the island really understood how to keep the soil contained on the hillsides. Were such mechanisms in place before the temple culture collapsed? Well, at some of our sites, there are indications of irrigation. At the Santa Verna temple, work by Chris Hunt has revealed certain what are they called? These, it's not pollen, it's like a not a phytolith, but spores of water-borne plant-like material that indicate there was a pool of standing water nearby. So this would not happen naturally in Malta. And it's this precise microscopic investigation of the soil that makes us able to infer that there were these management strategies in place at that time. Whether they were building things like terraces or physically moving the soil around is quite difficult to answer because of the huge scale of the more recent impact in the Maltese landscape with agriculture in recent centuries. But in prehistoric times, soil management and hydrological management were very much part of that particular package. So the answers of the questions are, it was a transformative impact, a sudden impact, and there were these strategies in place to manage the environment before the temple period was underway. How did a very small island community in prehistoric times manage to sustain dense and complex life? Now, this is the kind of question archaeologists are fond of posing, but it's very difficult to answer on any kind of empirical footing. We do know, however, thanks to seminal work by Ruben Grimna when he was doing his PhD in University College London, that the Maltese temple sites are located close to modern day toponyms, names that refer to water. And work as part of the project led by Alistair Ruffell identified geological faults associated with temple sites that crack down into a perched aquifer underneath the surface of the land and leads to the availability of fresh water. It is one of the unique things about Malta that fresh water, despite an environment with low rainfall and despite it being, there's no streams or permanent pools in the surface, there are quite a lot of springs, and this is a consequence actually of its geology. And the temples do seem to be located in places that where the water comes to the surface, and thus were probably deliberately, well, it's tempting to speculate that they're deliberately situated perhaps to control access to this or to celebrate this. Were the monumental temples instrumental in the process of sustaining cultural life? Well, I think for a time period that we've referred to as the temple period, it's hard to get away from any conceptualization of Maltese prehistory where the temples didn't figure large in sustaining cultural life. Our excavations at Santa Verna recovered for the first time the layout of that temple, which is very similar to neighboring Gigantea, and both are orientated on the winter solstice sunrise. Caroline mentioned scholastic alignments at Menidra and other temple sites. So I've got alignments to the equinox. Quite sophisticated modeling work using virtual reality techniques by our colleague Robert Barrett revealed that rather orientated towards a single calendar point, you know, like Stonehenge or something that's orientated upon a single day in the calendar, these temples were built to really accommodate and welcome the light of the sun during certain weeks. So there was a phase of the year where things were brightly illuminated and other times when they were in the dark. Temple sites are often also associated with certain motifs, and our excavations at Santa Verna revealed quite a few of these little interesting snail figurines, which are rather modest little artifacts in themselves. But interestingly, snails proliferate in the Maltese landscape in the winter months during this solstice alignment. And even today, they are celebrated. They're feasted upon. So it's we begin to see a very strong relationship between temples and their situation on the landscape, temples and their situation with respect to cosmology, and the importance, or maybe the primacy, of resources, especially food, in this setting. So culture sustained dense life in prehistoric times, and this was a culture that was a celebration of the environment. Next question. What sort of agriculture was used and what did people eat? This is significantly easier to answer. Our excavations revealed a Neolithic style economy where sheep and goat were by far the most important domestic animal. Cattle, pig present, but not particularly important. And cereal agriculture represented by the plant macrofossils you see at the bottom, which were very commonly found in our excavations. Wheat, barley, lentils, peas, beans, typical Neolithic cultivars. Were there failures in the food supply? Well, from the temple period excavations at the Shara Circle, we know that the health of the people was actually, on average, rather good, quite good by prehistoric standards. But there are certain cases of individuals that suffered during the course of their lives with occasional starvation or other forms of dietary stress. And here's one such example. This is several children whose bones were unearthed at that site who suffered from scurvy, vitamin C deficiency. So it seems that there were occasional episodes of dietary stress or time periods over the course of the life of these poor young individuals where certain nutrients weren't quite up to the job of keeping them alive. What impact had diet, disease, and stress have on the population? Well, when you have tens of thousands of teeth, you can do some quite interesting big data style analysis and actually count up the frequency of pathologies over time and map them out. So the impact of disease and stress was very low during the early parts of the Temple period, but near the end of the Temple period, as we get close to this magic 2500 BC date, we get indicators of stress becoming more commonplace. The prevalence rates of enamel hypoplasia, which evidences discrete moments of dietary stress in the life history of that individual, goes from very, really unusually low by prehistoric standards levels up to about 10%. Similarly, the prevalence rates of caries, tooth decay, which in Malta is very high by prehistoric standards, which shows a diet rich in carbohydrates or sugars. A healthy prevalence rate of caries today is extremely high because of our luxuriant Western lifestyles. But around 2500 BC, that becomes very low, indicating perhaps a change there. And also the number of people being buried in the site starts to fall off at around this time as well, indicating perhaps demographic pressure, just fewer individuals around, meaning fewer burials being made. So sheep, goat, cereals, and lentils is what sustained the people. There was occasionally failures in food supply, stress and decline from 2550 BC. What was the size and nature of the early Maltese population? Well, to answer this question, we can turn to the analysis of ancient genomes. Statistical modeling and simulation techniques undertaken by our colleagues in Trinity College Dublin, led by Dan Bradley, have managed to sequence the genomes of 3 Maltese individuals, and one of whom is a rather an interesting pedigree, if you like. It's now understood that there are certain cases from around prehistoric Europe where we have individuals from Ireland, where I am from. There is one case of a individual who was buried at a Neolithic grave, who's the offspring of a first order incestuous union. And second to that individual, one of our ancient Maltese individuals from the Shire Circle is the second most inbred prehistoric individual ever discovered. But unlike this Irish person, the Maltese person wasn't the offspring of some kind of first order incestuous union, but rather someone whose own parents and whose own grandparents and great-grandparents were a shall I say, interesting combination of cousins and second cousins and third cousins. And there is a strange cycle of a closed loop inbreeding cycle present. Now, in many ways, this shouldn't be all that surprising. The amount of demographic connectivity that is present in any prehistoric society is limited. And indeed, even today, these genomic models do show that geography is an extremely powerful predictor of where people's genes tend to fall. So through other forms of modeling, through the analysis of the homozygosity of the genome, and by applying some new methods, actually, they've been able to develop an estimate of the so-called effective population size for these 3 individuals of 382 people. Now, effective population size is significantly smaller than the actual census population size because it refers only to the demographically active sort of part of any given society. But for Gozo in the Temple period, it seems that there was an effective population size of 300 or 400 people, and you multiply that by 2, 3, 4, or 5 to get the actual census population size for that island. Gozo comprises about 1/5 of the Maltese archipelago in total. So we're looking at about 5,000, 6,000, 7,000 people, maybe, which is actually a fairly healthy population. In the medieval period, And in the early modern period, well, in the 16th century, there was 20,000 people living in Malta. Work as part of the project by our colleague Gianmarco Alberti has looked at the being able to extrapolate from early modern land intensity maps that were done for select parishes on Malta, an entire surface of the island, just to see where these 20,000 people were living in the early modern period. So it seems that even in, and if we then consider the population of late Neolithic Malta numbering in the thousands, it seems that these green areas in the map shown here would have been fairly densely settled, even far back in prehistory. What role did demographic connectivity or immigration play? Well, from the genetic evidence, very little, although we have anecdotal evidence from inspecting the human remains that there certainly was some incomers coming from both Africa and maybe elsewhere in Europe. We looked at strontium isotopes to see if we could detect any incomers with them, and we couldn't, partly because neighboring Sicily's got a very similar strontium signal. But our archaeological excavations did reveal quite a significant amount of raw materials, chert coming in from Sicily, and obsidian coming in from elsewhere in the central Mediterranean. And also at the end of the temple period, we start to see cultural influence from abroad with the rather unique pottery styles of the temple period becoming enveloped into the wider, very early Bronze Age style of thermi ware. So 6,000 people, raw materials provide the evidence for connectivity. Was there a social and environmental collapse at the end of the temple culture? No, there was not. What instead we see is a pattern of gradual decline. And it seems sudden in our rear view mirror from prehistory, but the reality was it was a decline that set in at around 2550 BC and really took until 2350 BC to fully sort of dematerialize into something else. So over a couple of centuries. That's sudden when we speak of millenniums and after millennia, but it's in terms of a lived experience, it's rather slow. Was there a hiatus between the temple culture and the later Bronze Age settlers? Well, no, there wasn't, but there could have been a hiatus early in the Bronze Age, and this, I think, has been a point of confusion for Maltese prehistory up to now. The dwindling amount of activity that we detect from the acme of the Tarshian phase of the temple culture down to 2350 BC continues. And by 2200 BC, we give very little evidence of any activity occurring, at least from an archaeological perspective. And this coincides with a quite well-known event, the 4.2 kilo-year climate event that really did change weather patterns around the Mediterranean basin. Significantly, our work, however, revealed a much more serious and much more important problem for Maltese prehistory, which is an almost complete absence of any direct archaeological evidence for human activity between the early Neolithic phases of the 6th millennium BC and the temple culture, which started in the 4th millennium. So we've got 1,000 years of seemingly absence of evidence. And whether that's absence of people, well, that's debatable. So I just wish to finish by pointing out the two themes that really have been able to tie our work together. And this is a huge project, generously funded by the ERC, and it involves dozens and dozens of people. But I think they might all agree with me. There are two unifying things. One is to do with soil. It is a precious resource now and in prehistory. The degradation that we see in Maltese soil was partly a natural product of the Holocene evolution, but it was very also to do with overexploitation and processes of aridification that the people simply couldn't hold back. The thinning of soils in upland zones and the thickening of soils in valleys led to a landscape that was much more difficult to work and ultimately led to the end of the temple culture as we know it. The other thing is chronology. Without chronology, we can't make sense of any of these data. Our excavations have been done with that explicit aim of making sure that each strata we can date somehow using radiocarbon dating or other methods to tie these things together. And it is through being able to really assess the likely chronology of all our discoveries that we can come to these, we can answer these questions that have been posed. So that's the answers. Now for the impact.
Well, thank you, Rowan. The science obviously is going on, but the important thing is we can begin to see a fluctuating, pulsing world in early Malta. It's a microcosm of the world beyond. It's like a tiny place that it reflects for us, I think, what climate change and soil degradation and overpopulation and overexploitation can do to a place. And this is just a pinpoint in prehistory. But to finish off, we just want to talk a little bit about the academic impact. And the important thing of a big project and an ERC project especially is the enabling of younger scholars to take up the opportunities of research on really important questions, to participate in laboratory and field work and lab work generally, and to be able to participate in the production of the publications. And I've lost count of how many, but there are dozens of papers now, dozens of conference presentations, many seminars, several PhDs are now successfully awarded, a Marie Curie Fellowship, many postdocs, and proper jobs and promotions. So as part of all of this, it has been wonderful to be able to see young people really benefit from the opportunities that have been offered by our very kind colleagues in Malta and by our partner universities. And so far, we've managed to produce 2 of the volumes, which are now available online and actually in the flesh too. And the 3rd one is soon to follow. So hopefully all this excavation is never going to be forgotten or lost. And like Scorba, as printed and published by the Antiquaries here, this will be a monument to these many excavations and these many data. And the impact obviously can be felt further afield through public open days. We were very keen that the communities in Malta and Gozo would participate. So we always had open days. We had a major big conference that tallied also with a 6-month-long exhibition in the National Museum, where we reproduced pollen grains at enormous size and had school days and all sorts of things. So altogether, this has been a wonderful project. We're very grateful to the European Research Council. It's one of the really precious things when you can have €2.5 million to throw at a big problem like this and make use of, and it's something we have to treasure. And so I want to acknowledge that the former High Commissioner from Malta was able to come to us before and launch the project, and the very many students and hard workers, everybody, thank you very much, and thank you for listening.